Thank you for watching a Gore Math Circle. My name is Jerry Yang, and today I'll be explaining the Junior Advanced Fractions and Operations Part 2, Session 5. So, first we'll go on a 5.1 review. So, last session we learned about divisional statements and how they're fractions, and how they can be expressed like this, 4 over 5. It means 4 divided by 5. And how fractions can be added, subtracted, multiplied, and divided. So if we do a couple of review problems here, so let's first do 4 over 5 times 1 over 5. So like you learned last time, you can basically just multiply these directly. Meaning that basically you can just multiply 4 by 1, which you get 4, and then 5 by 5, which is 25. So then our answer to this one is 4 over 25. The next problem is 4 over 5 divided by 1 over 5. And as you know, we have to take the reciprocal of this in order to actually turn it into a multiplication statement. So what we do is 4 over 5 times, and the reciprocal of 1 over 5 is 5. So we do 5 over 1. And then now we can just do simple multiplication like we did over here. And then now we get 20 over 5, which also equals 4. And in this session, we'll be learning how you can actually simplify this and make it easier to solve. And this problem is actually addition. So we have 4 over 5 plus 3 over 2. And as you remember, you have to have the same denominators. So then we find that 5 times 2 equals 10. That's the least common multiple of both of them. So then we have 10 over 2 times 4, which is 8, plus 5 times 3, which is 15 over 10. And if we add these up, then we get 23 over 10, which is our answer for this addition problem. Then, for this subtraction problem, you do similar things. You still have to have the same denominator. So then we have the same thing, 8 over 10 minus 15 over 10. And in this case, we can see this number will be a negative number. So then if we subtract it out, then we'll get 7 over 10. Negative 7 over 10. So continuing on to 5.2, fraction operators. So we already reviewed how to do like addition and subtraction from last session. So now let's look at a useful way for multiplying and dividing fractions. So we have the same equation over here written 2 times. So let's first do it how you were taught last session. 4 over 5 times 1/2. Now you'd normally multiply these two, and then you'd get 4 over 10. But there's actually a much better way to do this. And the way to do it actually is, it simplifies it much easier. Because over here you can see you can simplify it, but that takes more steps than if you just did it in the equation. So we can see this multiplication, you can actually cancel out these two. So if we cancel out this one and cancel out this one, then we get 2 over here and 1 over here, because we divide both of them by 2. Basically meaning that this is now 2 over 5 times 1, which is 2 over 5. Much more simpler than having to simplify this into 2 over 5. So this not only works for multiplication, but also division. But only those two equations. Don't try it for addition or subtraction. So this is an example of how it works for division. So we know we have to get the reciprocal of 1 over 5. So then we have 4 over 10 times 5 over 1. And now we can use the same principle over here, but flipped over here. So then we can cancel out this one and cancel out this one. We get 1 and 2. So we get 4 over 2, which basically equals 2. So then these are some practice problems, and I'll just do them for you in case you still don't understand some concepts. So 1 over 3 plus 1 over 4. You multiply this by this and this by this. So then we have 4 over 12 plus 3 over 12, which equals 7 over 12. So that's how you get that one for addition. And then for this practice problem, we have subtraction now. So we have 1 over 5 divided by 1/10. And we know 1 over 5, not divided, subtracted. And we know 1 over 5 is actually 2/10. So then we have 2/10 minus 1/10, which equals 1/10. So that's our answer for that problem. And this final problem is division. So we have 1 over 5 divided by 1 over 10. And once again, we can use the reciprocal thing. So then we have 1 over 5 times 10 over 1. And we can, once again, use the property from over here. And we can cancel these two out, make this a 2, make this a 1, and we get that this equals 2. So lessons 5.3 and 5.4 focus on the LCD. Now what is the LCD? The LCD is the same as the LCM, but for the denominator, and only the denominator, so you can't use it for the numerator. So we have two sets of fractions here that we're going to use to help you understand what the LCD is. So the first set is 5 over 6 and 7 over 8. And you can see I'm going to use the latter because we take these two denominators and we put them in the latter. And then we see what number can divide both of them. Now we know it's 2 because 6 can divide by 2 and 8 can divide by 2. And then we add another ladder and then we get 3 and 4. And these two numbers are relatively prime, meaning that you can't divide both of them by a number greater than 1. Meaning that we know that our LCD for this specific set is 2 times 3 times 4, which equals 24. So our LCD for this one is actually 24. And then for the next set, we have 9 over 6 and 3 over 2. And you can see I already put them in the ladder with 6 and 2. And we need to see what both of these numbers are divisible by. And we know this is actually 2. So then if we divide both sides by 2, we get 3 and 1. And these two numbers are relatively prime because you can't divide both of them by a number larger. Because you can't really divide them past this. So then we get 2 times 3 times 1 times 1 equals the LCD, which we know is 6. So the LCD for this problem is 6. And then on to 5.4. So in 5.4, we practice with addition, subtraction, and using the LCD. So some of the steps so that we can use to add or subtract using the LCD is first, we find the LCD. Then second, we write equivalent fractions, which means that the denominators are the same. And third, we add and subtract the numerators. And fourth, we simplify if needed. So this is the example problem that's in the lecture notes, and we're going to do it. So we have 3 over 4 minus 6 over 12. And we can put them into a ladder, and we get 4 and 12. And we need to see what both of these are divisible by. And we quickly see that that is actually 4, because 4 can be divisible by 4, obviously, and 12 can also be divided by 4. So if we divide both of these numbers by 4, then we get 1 and 3. And we know these two numbers from before are relatively prime. So then we know the LCD for this specific set, for this equation, is 4 times 1 times 3, which equals 12, which also happens to be the base over here, the denominator over here. So then we have to change this denominator over to 12 and this numerator to match it. So we have 3 times 3 over 4 times 3, because 4 times 3 equals 12, as we can see over here. And then that equals 9 over 12. So then we know that the equation for this, when we write equivalent fractions, is 9 over 12 minus 6 over 12, which equals 3 over 12. And using the step 4, we can see we can actually simplify this fraction to make it 1 over 4. So we know our answer to this problem is 1 over 4. So lesson 5.5 is on ratios. So lecture notes say that ratios are similar to fractions. They're just written in a different way to represent, well, different things. So we're going to do some examples of how to convert a fraction to a ratio and then a ratio back to a fraction. So 5 over 4 in ratio form is, well, it's 5 to 4. And we know this because the numerator comes first, and then we have a colon, and then we have the 4 comes after the colon. And ratios use this symbol, called the colon, which we can see between the two numbers. And when we convert ratios back to fractions, it's the same format. 7 to 2 in fraction form would be, well, 7 over 2. Because as you remember, 2 is the denominator and 7 is the numerator. So even if they don't write it that way and they don't say that, you know that if they ask you for a ratio in fraction form or a fraction in ratio form, that's how you do it. So if we use this in the real world, an example is 3 apples to 2 bananas can be written as, well, 3 to 2 in ratio form, or 3 over 2 in fraction form. And this is actually very practical for figuring out things like how much to buy or ratios for example, recipes. So we also have to know how to convert ratios to fractions and then to decimals. So what is the decimal form for 3 to 4? This is an example problem. Well, so we know 3 to 4, as seen above, equals 3 over 4, which is the ratio to fraction conversion. And then we have to have the fraction to decimal conversion. And how we do that is we can do division. So 3 divided by 4. And what we do is we can see that this equals 0.75. Because if we do this out, then we have, obviously, 4 cannot divide by 3, so we have to add a 0 over here. And we add this 0 point, and then what multiple of 4 goes in 30? Well, we have 28, which is 7, which is how we get the 7. So we have 28, and then we subtract this, we get 2, and then we have to add on another 0, and then that's how we get the 5. So we know that the decimal form of 3 to 4 is 0.75. And we figured that out through converting it to fraction form and then to decimal form. So 5.6 is converting fractions to decimals. So our example problem over here is 9 over 4. And we already tried this with ratios to decimals, but this time we're going to be doing it with fractions to decimals. So in order to put it in decimal form, we actually have to divide 9 by 4. So we have 9 divided by 4. And we know that it's 2, and then we have 8, and we subtract it, it's 1. So this is long division. And then we have to add on another 0 and add a decimal point, and 4 goes into 10 2 times, making this 2 and this 8. We'll subtract it again, and it's 2. And then we add on another 0, and 4 actually goes in, 20 can actually be divided by 4 to equal 5, with no remainder. So then we subtract 20, and then we get 0. So we know this is 2.25. So solving fractions can turn them into decimals, because the form of fraction, which we can see is, like, for example, is 9 over 4. This actually means 9 divided by 4, which is what they mean by solving a decimal. And this is a pattern that will actually be really helpful for the practice problems on the lecture notes. It's 1 over 10 equals 0.1, 1 over 100 equals 0.01, 1 over 1000 equals 0.001. And we can quickly see that this is an infinite pattern that helps for decimals. And this actually helps because you can see 0.1 looks a lot like 10, but it's reversed. And there's a decimal point in the middle. And then we have 0.01, which is 100, but reversed. And we have a 0, and then a decimal point, and then the part after it. And basically what we can see is that what this is you basically write the number, you can write the denominator backwards, and then put a decimal point after the first 0 to get this infinite pattern. So, yeah. So lesson 5.7 is on converting fractions to percentages. So percent means out of 100. So for example, 5% equals 5 over 100, which equals 0.05. 50% equals 50 over 100, also known as 1/2, which is equal to 0.5. And 100% equals 100 over 100, which is also known as just 1. So we can see that 8% equals A over 100. So to solve the percent of a number, you divide the number in the percent by 100, then multiply that by the number given. For example, 10% of 50. So we do 10 divided by 100, which then gets us 1 over 10. And then we do 1 over 10 times 50, which equals 5. So we know our answer over here is 5.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!